Determine the first 5 terms of each sequence given the sequence formula. To determine the terms of the sequence, we substitute the value of n given by the subscript, which indicates to find a sub 1, we substitute 1 for n. A sub 1 equals 5 plus 3 times 1. Following the order of operations, we multiply before we add. Simplifying, we have 5 plus 3, which is 8. To determine a sub 2, we substitute 2 for n. A sub 2 equals 5 plus 3 times 2, which is 5 plus 6 or 11. To determine a sub 3, we substitute 3 for n. A sub 3 is 5 plus 3 times 3, which is 5 plus 9 or 14. You may begin to notice a pattern. Notice that terms are increasing by 3 each time, which indicates to find a sub 4, we could just add 3 to 14. Notice we're adding 3 because of the coefficient of n. The coefficient of n is positive 3. Or we can just keep performing substitution. A sub 4 is equal to 5 plus 3 times 4, which is 5 plus 12 or 17. A sub 5 is equal to 5 plus 3 times 5, which is 5 plus 15 or 20. Again, we do have a pattern of addition, and this is an arithmetic sequence. Next, we have a sub n equals 5 times 2 to the power of n. To determine a sub 1, we substitute 1 for n. A sub 1 is 5 times 2 to the first, which is 5 times 2 or 10. To determine a sub 2, we substitute 2 for n. A sub 2 is equal to 5 times 2 squared. Again, following the order of operations, we simplify the exponents first. 2 squared is 4. 5 times 4 is 20. A sub 3 is equal to 5 times 2 cubed. 2 cubed equals 8. 5 times 8 is 40. Again, we may recognize a pattern. 10 times 2 is 20. 20 times 2 is 40, which indicates a sub 4 is going to be 40 times 2 or 80. Performing substitution, we have 5 times 2 to the 4th power, which is 5 times 16, which is 80. And a sub 5 is equal to 5 times 2 to the 5th. 2 to the 5th is 32. 5 times 32 equals 160. Notice here we have a pattern of multiplication. We multiply the previous term by 2 to get the next term in the sequence. This is called a geometric sequence. And finally, we have a sub n equals negative 1 to the power of n minus 1 divided by 3 to the power of n. To determine a sub 1, we substitute 1 for n. This gives us negative 1 to the power of 1 minus 1, or the power of 0, all divided by 3 to the first. Negative 1 to the 0 power is 1. 3 to the first is 3. A sub 1 is 1/3. To determine a sub 2, we substitute 2 for n, which gives us negative 1 to the power of 2 minus 1, or to the first power, divided by 3 squared. Negative 1 to the first is negative 1. 3 squared is 9. A sub 2 is negative 1/9. To find a sub 3, we substitute 3 for n, which gives us negative 1 to the power of 3 minus 1, which gives an exponent of 2, divided by 3 cubed. The square of negative 1 is positive 1. 3 cubed is 27. A sub 3 is 1/27. To find a sub 4, we substitute 4 for n. This gives us negative 1 to the power of 4 minus 1, or the cube of negative 1, all divided by 3 to the 4th power. The cube of negative 1 is negative 1. 3 to the 4th is equal to 81. A sub 4 is negative 1 divided by 81, or negative 1/81. And finally, to find a sub 5, we substitute 5 for n. This gives us negative 1, the power of 5 minus 1, which gives us an exponent of 4, all divided by 3 to the 5th. The 4th power of negative 1 is positive 1. 3 to the 5th power equals 243. A sub 5 is positive 1 243rd, or 1 divided by 243. Notice here the signs are alternating. This is called an alternating series. I hope you found this helpful.